Alright, so we're looking at the warm-ups here for implicit differentiation. So this problem asks us to find the dy dx for this problem. And we have to use implicit differentiation for this. We can't use explicit differentiation. Explicit would mean we'd have to be able to solve for y. This is unable to be solved for y. So therefore, we have to find the derivative implicitly. So we say the derivative of 2 sine x is going to be 2 cosine x. And it's really 2 cosine x dx dx, but we don't have to put that because it's 1. The derivative of 5 cosine of something is going to be negative 5 sine of that angle. Then you have to do times the derivative of the angle. So the derivative of 3y is going to be 3 dy dx. And I bet a lot of you forgot that 3. Make sure you have it. The derivative of 8 is going to be 0. So now we're just going to clean this up a little bit. That stays the same. Negative 5 times 3, that's going to be negative 15 sine of 3y dy dx, 0. To get dy dx by itself, we have to take 1 over to the other side. I like this. You chose to take this one over just to make it a positive. And so then all we have to do to get dy dx by itself is divide those sides by 15 sine of 3y. Excellent. Questions on that? Did some of you forget that 3 in the chain rule? I would think that would happen. Once again, let me just go back up there one more time. Derivative of 5 cosine of something is negative 5 sine of that something, but then you have to do the derivative of 3y, and that derivative is 3, and because it's a y and not an x, we have to put dy dx in there. All right, great. The second problem, we were trying to figure out where we would have horizontal and vertical tangents. Okay, so looking at Casey's here, I'm just going to jot down the original problem. It was x squared plus 6x plus y squared equals 7. So the derivative of x squared is 2x, derivative of 6x is 6, this derivative is 2y dy dx, and this derivative is 0. So now we had to solve for dy dx, so we took over the 2x, took over the 6, and then he had to divide by 2y. So he gets this. So in order to find where we have a horizontal tangent, the directions said find the points where there would be a horizontal tangent and vertical tangent for that function. So to find where we have the horizontal, he sets the numerator equals to 0, solves it, and he gets negative 3. How did you find this value then? Okay, so plugging back into the original, negative 3 squared is 9, minus 18 plus y squared equals 7. So we have negative 9 plus y squared is 7, y squared is 16. But what should he have? Not just negative 3, 4, but what else? Negative 3, negative 4. Because when I take the square root of that, anytime I have y squared equals 16, I take the square root of both sides, that's going to be y equals plus or minus 4. So that's why we should have 2 right there. Then to find out where we would have the vertical tangent, we have to set that denominator equal to 0, because we need for the slope to be undefined. dy dx is just our slope. So 2y equals 0, that means y is 0. And how did you find those two x values? Okay, so back up into the original. X squared plus 6x, that's 0, equals 7. So we have to subtract that. X squared plus 6x minus 7. In order to solve this, it's a quadratic. It has to get set equal to 0. We factor it. And so we get negative 7 and 1. And so that's how we got these points. This is a 1, right? Okay, so we have, yeah, not quite. You just didn't factor it right, did you? That's okay, we'll fix that. So that should be at negative 7, 0, and at 1, 0. So here would be the horizontals, and here would be the verticals. Did anyone find these answers without using calculus? Let's talk about how you could do this without even using calculus. What we could do is we could take that original problem here. Let me write the original again. And I can just complete the square. I want to figure out what does this look like. So I'm going to take half of 6, that's 3, square it, that's 9. So we're going to add 9 to both sides. How does this factor? X plus 3 squared plus y squared. 9 and 7 is 16. What is this shape now? Circle. What's the center of it? Anybody know? -3, 0. Some people said it. And what's the radius of it? So if I wanted to do this without calculus, I could go to the center, -3, 0. I could go out 4 units to the right. That's going to put me at 1, 0. I could go out 4 units to the left. That's going to put me at -7, 0. From this point, I could go up 4. That's going to put us at -3, 4. And I could go down 4, and that's going to put us at -3, -4. Here's what the circle would look like. See how right here I'm going to have a horizontal tangent? That's what we got for our answer. Another horizontal, and there's the 2 vertical tangents. So this problem could be done without calculus. Of course, since it's calculus class, I'd prefer you to do it with the calculus. But, you know, if you're taking a quiz or a test and it's multiple choice and you just have no idea how to do it with calculus, just do it that way. Complete the square, figure out what it looks like, and just figure it out by problem solving. Okay? You may have questions over that? All right. Let's go ahead and get out your homework.